This problem involves a bridge truss loaded by two forces, each equal to P. The truss is designed so that all angles are either 45 degrees or 90 degrees. My task is to determine the forces in the bar AB. This problem is best to be solved using the method of sections. The method of joints is too demanding, and most likely one will commit an arithmetic error while doing it. I will start with calculating the reaction forces. This is a basic free body diagram. The equilibrium equations are written using C as the pivot for the moment equation, and the answers are given here. Please pay attention that the forces are slightly shifted to the left, and this slight shift results in the forces, reaction forces, so that the force on the left is slightly larger than the force on the right. Of course, their sum is equal to P. Next, I will focus on the bar AB. I cannot cut this bar such that the cut will include only 3 bars. In this case, I show a very basic cut which involves 4 bars. And the resulting free body diagram, which involves the left section or the section to the left of the cut, involves 4 forces. The force of interest F, and then the auxiliary forces F1, F2, F3. So it is clear that to proceed, I need to compute one of the auxiliary forces. My first solution will involve the force F1, here denoted as the force in the yellow bar. Now, to determine this force, I can make an additional cut shown in yellow, and now you could see that the new cut cuts through 3 bars, and therefore we can look at the free body diagram and write down 3 equations for 3 unknowns. Here's the free body diagram associated with the yellow cut, and the primary unknown here F1, and therefore the natural equation will be sum of the moments about E, simply because it kills these 2 forces. And as a result, I find that F1 is a compressive force equal to 51 over 16p. Now, since F1 is known, I can get back to the original free body diagram and determine the force F. The easiest equation to write is sum of the moments about G, because it disengages the forces F2 and F3 and allows us to write one equation for one unknown. And that's the equation. And the answer is that F is equal to minus 9 over 8 square root of 2. So you could calculate what it is approximately, but I will keep the answer as is. Next, I would like to show you an alternative solution. In this case, the auxiliary bar will be the bar where the force is F2, and it is marked in yellow. To analyze this bar, I will look at the 2 joints. The first joint is this one, and it is clear that the free body diagram for this joint and projection of the forces along the vertical axis will tell me immediately that the force in this bar is equal to P, and it is tension. Once I determine this force, I will proceed to this joint. In this joint, I'm interested in the force F2, and to calculate this force, I'll project everything on the axis x prime, which is perpendicular to the line formed by the inclined bars as shown. The resulting equation is given here, and this allows us to calculate the force F2. Once F2 is known, we go back to the original free body diagram, and now we know the force F2. And now to find the force F, the easiest thing to do is to project all the forces on the y-axis. That's the equation, and that's the answer. And this answer is exactly the same as the one obtained with the previous method. Thank you.